Welcome to the deep dive. So you're here because you want to get more out of large language models, right? Like OpenAI's GPT-4.
Yeah, move beyond just the basic chat window stuff.
Exactly. Today, our mission is, well, to unlock the real power of these models for actual applications. We're going to dig into the tools and techniques you need to build some pretty impressive things.
It's getting super important to know how to go past simple prompts and, build more complex, even autonomous systems. Think of this as getting you up to speed on that next level of LLM power.
And we're basing this on sources that really highlight two main ways forward. First, using the OpenAI API directly.
Right, for raw access.
And second, using this framework called LangChain, which seems, well, incredibly useful for making things easier and adding more power.
Yeah, it streamlines a lot. We'll see how these tools help you go from basic Q&A to full automated workflows.
Okay, let's dive in.
So first things first, the absolute basic, sending a prompt to an LLM.
Right. Okay, how does that work at the ground level? Well, one way is just hitting the OpenAI API directly. Our sources show, you use some Python, import their library.
Authenticate with your key.
Yeah, exactly. And then you structure your request, as a message. The example we saw asks it to explain quantum computing in simple terms.
And you set roles. Right, like system says, you're a helpful assistant, and user is the actual question.
You send that off, get the explanation back. It's very direct. Input, output. Pretty clear.
It is. You're basically having a direct line to the model. Now, LangChain, it offers, let's say, a smoother path for the same result. It's like an abstraction layer.
Okay, abstraction, meaning it hides some of the fiddly bits.
Pretty much. It handles some of the background complexity.
Yeah, the LangChain code for the same quantum computing question looks, different.
Yeah.
You import things like chatOpenAI and human message from LangChain itself. Then you set up chatOpenAI, tell it which model, GPT-4 or whatever, and then just pass your question as a human message.
So you're still using OpenAI's tech under the hood, but LangChain gives you this more consistent interface.
Right. And that consistency really helps when things get more complicated, doesn't it? Less boilerplate code to worry about.
Definitely. Think of the raw API like building with loose Lego bricks. LangChain gives you some pre-built sections you can just snap together faster.
Nice analogy. Okay, so basics covered for sending prompts both ways. What's the next step up in, making these interactions more useful?
Well, often you're not just doing one-off questions, are you? You might need to handle a continuous flow of info or maybe lots of requests at once. And this is where LangChain really starts to show its value in handling that kind of data flow.
So instead of just waiting for the whole answer at the end, you can see it coming in piece by piece.
Exactly. LangChain has this thing, streaming speed out callback handler. Makes streaming super easy. Say you ask the AI to tell me a long story about a brave cat. With this handler, the story just starts appearing, word by word. As the LLM generates it, it feels much more live.
Yeah, that sounds way better for a user interface. Keeps you engaged instead of just staring at a spinner. And what if you have a list of questions? Say, what is AI and define machine learning? Do you send them one by one?
You could, but it's inefficient. LangChain has batch processing. There's a chat.bash function. You just give it your list of prompts, and it sends them off probably more efficiently behind the scenes and gives you back a list of the answers way faster if the questions are independent.
Got it. Like sending one big grocery list instead of running back for each item makes total sense for efficiency. Okay, so we've got the mechanics. Sending prompts, handling streams, batches, but the quality of the answer, that really depends on how you ask, right?
Absolutely. You've landed on, maybe the most crucial skill, prompt engineering. It's an art, really.
It's not just asking a question.
No, it's carefully crafting it to get what you actually need. And you almost never get it perfect the first time. It's iterative.
Iterative. Meaning you try something, see what happens, then tweak it.
Exactly. Like the source showed. Start simple.
Okay.
Summarize this article. Maybe that's too vague.
Right.
So you refine it. Summarize this article in bullet points. Focus on technical insights for developers. Much more specific.
And you get a better result, presumably.
Hopefully. The key is observing the output and adjusting. LangChain makes it pretty easy to quickly swap out prompts or change the context you provide to see what works best.
Okay, so learning to talk to the LLM better through trial and error makes sense. Now, what if you find yourself writing the same kind of prompt over and over, just changing a few details?
Yeah, that's super common. And that's exactly what prompt templates in LangChain are for. They let you create reusable structures.
Like a fill-in-the-blanks thing.
Basically, yeah.
Yeah.
You define the main text of the prompt, but leave placeholders for the bits that change.
Can you give an example?
Sure. The source had one for translation.
Huh.
Translate text to language. See, text and language are the placeholders. Then you could just plug in, say, hello for text and French for language. It builds the final prompt for you. Really good for consistency and just saving time when you do similar tasks a lot.
That seems really practical, especially for bigger applications. Avoids retyping and keeps things standard. Okay, so we have individual prompts, reusable templates. How do we start chaining these things together for, like, multi-step tasks?
Right. This is where it gets powerful. LangChain has something called the LangChain Expression Language, or LCEL. It's designed for composing components together.
Composing, like linking them up.
Exactly. You can take a prompt template, the LLM model itself, maybe an output parser, and pipe them together into what they call a declarative chain.
Declarative. Okay,
Yeah.
What does that mean in practice? Like, you say what you want done, not every single step of how.
That's a good way to put it. The source had a fun example.
Yeah.
Telling a joke. Step 1, a prompt template like tell me a joke about topic.
Okay.
Step 2, the chat OpenAI model. Step 3, a simple parser to just get the text out. Then you use this pipe symbol to connect them.
Oh, I saw that symbol.
Yeah. Template model parser. The output of one flows straight into the next. Define it once, then just call it with a topic like AI, and boom, you get a joke.
That pipe thing looks really clean visually, makes it easy to see the flow.
It does. LCL makes things very modular and easier to understand, build, and debug, especially for complex workflows. But what if you need to stick some of your own custom logic in there?
Like maybe change the LLM's output before the next step? Or pre-process the input?
Precisely. LangChain lets you do that with custom runnables. You can basically wrap any Python function using Runnable Lambda and slot it right into your LCL chain using the pipe operator.
Oh, cool.
The example showed taking a joke topic, running it through a custom uppercase function before sending it to the LLM.
So you could use that to, I don't know, enforce formatting or apply some business rule right inside the chain.
Exactly. Adds a ton of flexibility for integrating your own code or data processing steps. Now, we've seen chaining things sequentially. What about doing things side by side? At the same time.
Like parallel processing.
Yep. LangChain supports that too, using runnable parallel. You basically set up a dictionary where each key is like a name for a parallel branch, and the value is the chain you want to run in that branch.
The source example was generating jokes in English and Spanish simultaneously, right?
That's the one. They had one branch with the prompt for cats and another for gatos, both fed into the LLM and parser in parallel.
And the output was?
A dictionary with both the English and Spanish jokes generated at roughly the same time. Super useful for multilingual stuff. Or maybe running different kinds of analysis on the same input concurrently. Big efficiency wins sometimes.
Okay, parallel processing, check. Now, thinking about conversations, they aren't always just one shot, right? You need nuance, context.
Definitely. And understanding chat message types is key here. In chat models, messages usually have a role.
Yeah.
System, user, or assistant.
Right. System sets the stage, like tells the AI who it should be. The source mentioned making it a kind tutor.
Exactly. The system message gives the AI its overall instructions or persona. User is, well, you, the human. And assistant is the AI's replies.
Okay.
Using these roles helps structure the conversation and guide the AI. You could even put examples in the initial messages, like showing it the kind of answers you want that's called few-shot learning.
Giving it examples.
Or even showing it how to think step by step, which is called chain of thought reasoning.
Yeah.
Helps it produce more reasoned responses.
Gotcha. It's like giving the AI stage directions and a bit of rehearsal. Now, for a chatbot to feel real, it needs to remember stuff, doesn't it?
Oh, absolutely. Context is everything. Otherwise, it's like talking to someone with severe short-term memory loss after every sentence.
Yeah. Frustrating.
LangChain has memory components for this. Conversation buffer memory is a common one. It just keeps track of the messages back and forth.
And you plug this into a conversation chain.
Yeah, and the chain automatically handles saving the history and including it in future calls to the LLM so it knows what was said before.
So in the example, if I say hello and then later ask, what did I just say?
The AI, using the memory, can actually recall your hello. It's fundamental for making chatbots that feel coherent and, well, useful.
Makes total sense. Essential for persistence. Okay, switching gears slightly. What if you need the LLM to give you back information in a specific format, not just a blob of text?
Yeah. Parsing free text is messy and unreliable. You don't want to do that if you can avoid it.
So how do you enforce structure?
LangChain has output parsers.
Hmm?
A really powerful one is Pydantic output parser. You use Pydantic, which is a Python library for data validation, to define the exact structure you want, like define a class with fields and types.
The source had an info model, I think,
Yeah.
with topic and summary fields.
Exactly. You define that structure, tell the parser about it,
Oh.
and include instructions in your prompt telling the LLM to format its output according to that structure. You pipe the LLM output into this parser. And then, instead of raw text, the parser gives you back a nice, clean Python object matching your defined structure. The topic is in the topic attribute, in the summary attribute. Type-safe, predictable data.
Wow, okay. That's huge for building applications that need to use the LLM's output reliably. No more messy text scraping.
Definitely. Now, another common challenge.
Yeah.
What about really long documents, too big to fit in the LLM's input window?
Yeah, you can't just paste a whole book in there.
Right. So LangChain provides text splitters. Recursive character text splitter is a smart one. It breaks the long text into smaller chunks.
Just cuts it arbitrarily.
It tries not to. It looks for natural breaks like paragraphs, sentences, trying to keep related text together within each chunk. You can control the chunk size and overlap between chunks too.
Okay, so you split your giant document into manageable pieces. Then what?
Then you can process each chunk. Maybe run a summarizer chain on each chunk or extract keywords or do sentiment analysis. Then you might combine the results from all the chunks.
Ah, I see. So you can tackle huge amounts of text indirectly by working chunk by chunk. Useful for analyzing reports, books, whatever.
Yeah, opens up analysis for documents that would otherwise be too large.
Mhm.
Tagging, analysis, summarization, lots of uses.
Okay, we're building up quite a toolkit here. Handling long docs, getting structured output. What's the next level for making these LLMs truly useful in the real world?
Well, often the LLM's built-in knowledge just isn't enough, right?
Yeah.
You might not know today's weather or how to do complex math accurately or access your company's database.
True, it's trained on past data.
So you need to give it tools, external tools.
Yeah.
And LangChain lets you do this with agents.
Agents. Okay, tell me more.
Think of an agent as an LLM that can use tools. LangChain provides ways to load tools. The source mentioned using SirPoppy for web search.
In LM math for calculations.
Right. You give the agent an LLM and a list of tools it's allowed to use.
And that?
Then you give the agent a task that likely requires those tools. Like, what's the weather in Tokyo right now and what's 15 times 8?
And the agent figures out which tool to use for which part of the question.
Exactly. It reasons. Okay, for weather, I need the search tool. For 15 times 8, I need the math tool. It calls the tools, gets the results, and then synthesizes a final answer for you.
That's amazing. It overcomes the LLM's own limitations by letting it reach out.
It's a huge step, but we can take agents even further
Oh.
towards truly autonomous systems. Agents that don't just use tools when told, but can actually reason, plan, and decide when and how to use multiple tools over several steps to achieve a complex goal.
So less direct instruction, more delegation.
Kind of. You
Yeah.
give it a high-level objective, and the agent figures out the strategy, which tools to use in what order, maybe even learning from mistakes. LangChain's agent framework has the building blocks for creating these kinds of sophisticated decision-making AI systems.
Wow. Okay, so we've gone from just asking a question to building AI systems that can figure out how to find the answer using external resources. That's quite a journey.
It really is. We've touched on a lot. Basic prompting with the API versus LangChain.
Handling streams and batches efficiently.
The whole art of prompt engineering,
Yeah.
using templates,
Building pipelines with LCEL, adding custom code.
running things in parallel,
Yeah.
the nuances of chat messages in memory,
Getting structured data back, handling huge documents.
and finally giving LLMs tools and building towards these autonomous agents. It's a whole progression.
It really shows how these tools let you build layer upon layer, creating much more powerful and flexible applications than just simple chat. It really highlights the potential here.
Absolutely. And maybe, as you think about all this, consider which parts could really change how you work or explore things you're interested in. That ability to automate interactions, structure data, connect to tools. Which of these techniques feels like the next step for your own goals? Something to chew on after our deep dive today.